Module 8, Lesson 4 covers direct variation, which is very closely related to slope. In fact, direct variation has something called the constant of variation, which is just another name for slope. The pacing guide claims we're going to have 90 minutes worth of lesson as we go into this, which will be pretty impressive considering there's only 14 resources in it. Koalas, that's those cute little fuzzy bears, eat a pound of eucalyptus leaves a day, which requires a great deal of energy to digest. Now stop and think about this. They eat leaves for energy, but it requires a lot of energy to digest the leaves they ate. Okay, fine, whatever. To conserve their energy, koalas sleep 18 to 22 hours a day, kind of like some of you teenagers would like to do. Suppose the number of hours a koala sleeps is the unit rate, and if the koala sleeps 18 hours each day, what steps can you take in order to write an equation that expresses the relationship of the number of days, x? These are some of the things we're going to be looking at as we get further into this lesson. Now our inquiry question, it asks, how can you use the slope formula to derive an equation for a proportional linear relationship? And we're going to take and play around with some e-tools here to figure that out. The table shows the amount of money that David raised during a bike-a-thon. The graph shows, and we're taking and graph this relationship on the coordinate plane. So let's zoom way down here so we can see everything for just a minute. Where you've got where 0.00 is where he started, and then he has where x is 2, y is going to be 20. So we've got x is 2, y is 20, and we have where x is 4, y is going to be 40 right here, and then we have where x is 6, y is going to be 60. And if you notice, that is creating a linear relationship. It's creating a straight line, and any point along here, you're going to end up getting the same slope. When the ratio of two variable quantities is constant, a proportional linear relationship exists. Linear means it's going to make a straight line. It also means it's going to have the same slope. The proportional linear relationship is going to be called a direct variation. So we'll go ahead and highlight all of that. It's going to be the first vocab term. The constant ratio is going to be called the constant of variation, also known as the constant of proportionality. And you want to know what else it's called? It's called the slope. And you can see that you have the formula here that says y is equal to m times x. What did I tell you m was equal to? M is always going to be your slope, and it also represents your constant of variation. It also represents your constant of proportionality, and it's going to be written as a unit rate. Flipping our cards over here, we can say that a direct variation is a linear relationship in which the ratio of y to x is a constant. We say that y varies directly as x, and that part right there, y varies directly with x. Anytime you see that term, you need to stop what you're doing and write down y equals mx to represent the fact this is going to be a direct variation problem. You're going to need that. From here, we can look at it as a graph. You can see that you've got y is equal to 2 times x, where 2 is going to be your slope. And then we could also look at it as symbols, which says that the slope is equal to the y divided by the x. And if you were to take and multiply x on both sides to isolate the variable, then you would be able to say that y is equal to m times x, where of course m is not going to be equal to a slope of 0. And finally, looking at it as an example, y equals 2x. I believe that's the same thing we saw here. Yep, that would be an example of a direct variation equation. Y is equal to your slope m, which in this case is 2, times x. The slope of the graph y equals mx is going to be m. Okay? M is always going to be your slope of these. And since 0.00 is one of the solutions of y equals mx, it is going to be a direct variation. For the graph to be a direct variation, it has to go through the origin. It has to go through point 0, 0. If it does not go through point 0, 0, you cannot use the formula y equals mx. It's just all part of how it works. Now, of course, you can use the slope formula to derive the direct variation equation. Here we've got 2 points where you're going to take and say that the y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Put in whatever your values are for your y and your x there, and of course when you subtract 0 from each of them, you get y divided by x, and that's going to equal to your slope. Finally, from there, if you were to take and multiply x on both sides, you would end up getting y is equal to m times x, otherwise known as y is equal to your slope times your x value. Example 1 deals with the cost y of gymnastics lessons varies directly with the number of sessions x. And somehow I'm thinking that this isn't real accurate because I paid for gymnastics lessons and those suckers are expensive. So write the direct variation equation to represent this relationship, then identify the constant of variation and interpret its meaning. So first thing I want to do is point out right there, the graph goes through the origin. It goes through point 0, 0. And it also is a straight line, and because you have those two things, you know you have a direct variation. You also have 2 different points listed here on the graph, but in the end, we're only going to truly need one of them to work this problem. In this slide, they want us to find the slope, and they picked these 2 points right here, which are not the points I would have picked. I would have gone from the origin up to 10 and over 1, because there you get 10 over 1, which is 10. I mean, that's super easy, right? Instead, they went from 10 to 20, which is still a rise of 10, and from 1 to 2, which is still a run of 1. So you're still going to get that 10 over 1 slope, and of course you could just write that as 10. You don't have to take and put 10 over 1 when you can see right there that that's exactly what they did. They wrote their slope as 10 for the final answer on that. Next slide says that they want you to take and evaluate m for the equation. So they have y equals m times x, and if we were to take and plug it in, that means that we have changed that m to be 10, because we said earlier that m was equal to 10, and that gives us the actual formula or equation for that one that says y is equal to 10 times x. Now part B wants us to find the constant of variation and interpret its meaning. Well, the constant of variation, also known as the constant of proportionality, is also known as the slope. And we've already established that slope is m, and we already told you that 10 is m, so the slope is going to be 10 over 1, also known as 10, which is the constant of variation is going to be 10, and that means that every one lesson you do, it's going to cost $10. And now you get to pause the video and do extra example number 1. A grocery store is having a sale on ears of corn. The cost y of corn varies directly. There you have it. That means you got a y equals mx problem with the number of ears of corn, x, is shown on the graph. Write a direct variation equation to represent this relationship. Well, what do they want us to do first? They want us to come up with a slope, and if we were to take and jump over to here, remember your slope is going to be your rise over run, and there's lots of different points on this line that I could use, but I'm going to take and I'm going to use this one right there, because it's a nice intersection between 2 whole numbers, 1 and 4. So, starting at the origin, I'm going to rise 1, and I'm going to run 4. So what's my slope going to be? My slope is going to be 1 over 4, which we can also write as 0.25, but I like fractions, so that's what I'm going to do. 1 over 4, hit accept and check. So there we have created the equation of the line. Y is equal to 1/4 times x. What's the constant of variation going to be? The constant of variation is the slope. So we can take and type in 1 over 4 again, accept that, and that means that how much is each ear of corn going to cost? Well, what is 1/4 of $1? It is going to be 25 cents, and those two check. And that's all there is to doing this problem. Example number 2 tells us that the cost of bulk peanuts varies directly with the weight of the peanut. Right there it tells us it's a direct variation problem, y equals m times x. At a local grocery store, 2 pounds of peanuts cost $5.80. Write a direct variation equation to represent this relationship and then identify the constant of variation and interpret its meaning. So let's keep this going here. First thing we need to do is find the unit rate for M. That means we need to relate that 2 pounds for 580 and find out what 1 pound of it's going to cost. So 580 divided by 2, that means that's going to be 250 plus 40. That's going to be $2.90 is how much 1 pound is going to cost. So we've accomplished the first part. From there, if we go to step 2 that says write the unit rate of the equation, so we can just say that it's $2.90 for 1. That just means y is equal to $2.90, or I'm going to just try 2.9 times x, and it says that answer is good as well. Move on to down here, and of course you can see that's what they gave us for your direct variation equation. Y was equal to 2.9x. Next thing we're going to do is we're going to take and actually apply that and say, what does it mean? The constant of variation is your unit rate. The constant of variation is 2.9. That means the cost per pound of peanuts is going to be $2.90 for every pound of peanuts you get. Once again, it's your turn. Pause the video and work on extra example 2 here on your own. The length that a spring stretches varies directly, there it is right there, varies directly with the amount of weight placed on it. That varies directly tells you it is going to be a y equals m times x problem. When an 8-ounce weight is attached, the spring stretches 2 inches. Write a direct variation equation to represent this relationship, then identify. Well, think about this. If, let me jump over to our scratch sheet here, if we have a relationship where you've got a rise over run, where you have a rise is going to be 8-pound weight is equal to 2 inches stretch, that means that a 4-pound weight is going to be a 1 pound, and of course that would finally simplify to be just, well, excuse me, 1 inch, that would simplify to be just 4. So the constant of variation is going to be 4 over 1, also known as just 4. We're going to hit accept and check, and I wonder if they wanted to do this the other way. I wonder if they wanted it to be listed as 1 over 4. Let's try that. 1 over 4, accept and check. Now I'm really confused. Oh, they did want 1 over 4. I didn't realize that they'd not put in the x there. Let's say they let y represent the length of spring in inches. So, yeah, I definitely wouldn't have thought 1 over 4, 4 over 1. I guess that works too. So now we've got our formula that says y was equal to 1/4 x, where the constant of variation is going to be the same thing as the slope, which is going to be a 1 over 4, except that, and that means the spring stretches. What's 1/4 of an inch going to be? Is the same thing as 0.25 inches for every ounce of weight that's been added to it. For example 3, Aubrey is baking oatmeal cookies. I hope she doesn't put raisins in them. For the school carnival, using the amount shown in the table. The number of cups of flour varies directly with the number of cups of oats. Write a direct variation equation to represent this relationship and then identify the constant of variation. Well, your slope was your y divided by your x, so that would be your 4 divided by your 2. And how are they going to go about doing that? I would just do 4 over 2, which is not what they did. They said pick 2 points, because go back down here, you can see they ended up using the first row and the second row. So y sub 2 was 8 minus y sub 1 is 4. And that's what they did right here, 8 minus 4. And then they said that x sub 2 is 4 minus x sub 1 is 2. Here you've got your 4 minus 2, and that of course is going to take and simplified down. We would say that 8 minus 4, that's 4. 4 minus 2, that's 2. But is that in lowest terms? No, it is not. That's going to end up becoming 2 over 1, also known as just 2 for your final answer. Check it, and it checks. Now we get to use that value of 2 for the slope. So we're going to take where we have the m, we're going to take and plug in a 2, replace the m with 2, and that gives us our new formula, y is equal to 2 times x, to find out how many cups of oatmeal is going to require how many cups of flour. From here, we can take and apply that. The constant of variation is equal to slope. The constant of variation, we've already said, is 2, which means the unit rate is going to be 2 cups of flour per 1 cup of oatmeal. Hopefully this does a good job of showing you how these things are related and how you can use your slope, also known as your constant variation, to find out new values. From here, we're going to go on to our very last problem. We're going to knock out this lesson in a single video, which I always like. Less work on me, less watching on you. Go ahead and pause the video, work this one on your own. So Lucas recorded the number of calories he burned while jogging. The number of calories burned while jogging varies directly to the number of minutes jogged. That tells you right there that varies directly. We're going to have a y equals mx problem going on. Write the direct variation equation to represent this relationship, then identify the constant of variation and interpret its meaning. Now, we could take and do any 2 points on this line to get to where we want to go. You don't even really need 2 points because we know it's going through the origin, and since we know it's going through the origin, we could in the origin, because they said it varies directly, it's a direct variation, they have to go through the origin. So going way back in our Wayback Machine, one of the things that they taught us was that we could use this formula. We could say that slope is equal to y2 minus y1 over x2 minus x1, and we could do that where our y1 and our x1 are both going to equal to 0. Now from there, I want to pick some numbers that are easy to work with, and that pair of numbers is going to be these two. So my y2 is going to end up being 95, my y1 is going to end up being 10, and that means that 95 minus 0 is 95, 10 minus 0 is 10, and that simplifies down to 9.95 divided by 10. That is just going to be 9.5 to 1, also known as 9.5, or just 9.5. So my slope value is going to be 9.5, and I can jump back over to my problem here, and we're putting the equation that is going to be 9.5 times x, which we're going to hit accept and check. That part checked. So my equation is y equals 9.5x. The constant of variation is going to be your 9.5, and that means he burns 9.5 calories for every 1 minute that he exercises. That is it for this lesson. Get started on your homework. Make sure you are giving me good quality supporting work like the stuff I've been giving you, and I'll answer your questions in class tomorrow.